Welcome to the Shakaama Live Show with your host, Shakaama. Be sure to like and subscribe to the video. World's first living robot created using frog cells and artificial intelligence. Scientists use computer algorithms to quote-unquote evolve an organism that's made of 100% DNA of frog, but it isn't a frog. Now, I've spoken about robots coming from Japan and China and Asia in general. So let's come back to the Western countries. What happens when you take cells from frog embryos and grow them into new organisms that were evolved by algorithms? You get something that researchers are calling the world's first living machine, quote unquote. Though the original stem cells from frogs, the African clawed frog, Xenopus laevis, these so-called xenobots don't resemble anything amphibian. The tiny blobs measure only about 0.04 inches, 1 millimeter, wide and are made of living tissue that biologists assembled into bodies designed by computer models. According to the new study, these mobile organisms can move independently and collectively, can self-heal wounds, and survive for weeks at a time, and could potentially be used to transport medicine inside a patient's body, scientists recently reported. Quote, they're neither a traditional robot nor a known species of animal, study co-author Joshua Bogart, a computer scientist and robotics expert at the University of Vermont, said in a statement. Quote, it's a new class of artifact, a living programmable organism. Algorithms shaped the evolution of the xenobots. They grew from skin and heart cells, stem cells, into the tissue clumps of several hundred cells that moved in pulses generated by heart muscle tissue, said lead study Sam Kriegman, a doctoral candidate studying evolutionary robotics in the University of Vermont's Department of Computer Science in Burlington. Quote, there's no external control from a remote control or by electricity. This is an autonomous agent. It's almost like a wind-up toy, Kriegman told Live Science. Biologists fed a computer constraint for the autonomous xenobots, such as the maximum muscle power for its tissue and how they might move through a watery environment. Then the algorithm produced generations of tiny organisms. The best performing bots would reproduce inside the algorithm, and just as evolutionary works in the natural world, the least successful forms would be deleted by the computer program. Statements made in these news article do not reflect actual science, such as evolution, how it works in the natural world. Evolution is still quote unquote a theory, and it is summarily debunked oftentimes because it lacks the actual finesse of science. That is a side note. Quote, eventually it was able to give us designs that actually were transferable to real cells. That was a breakthrough, Kriegman said. The study authors then brought these designs to life, piecing stem cells together to form self-powered 3D shapes designed by the evolution algorithm. Skin cells held the xenobots together, and the beating of heart tissue in specific parts of their bodies propelled the bots through water in a petri dish for days, and even weeks at a stretch, without needing additional nutrients, according to the study. The bots were given able to even repair significant damage, said Kriegman. Quote, we cut the living robot almost in half, and its cell automatically zippered its body back up, he said. We can imagine many useful applications of these living robots that other machines can't do, said study co-author Michael Levin. director of the Center for Regenerative and Developmental Biology at Tufts University in Massachusetts. These might include targeting toxic spills or radioactive contamination, collecting marine microplastics, or even evacuating a plaque from human arteries, Levin said in a statement. Creations that blur the lines between robots and living organisms are popular subjects in science fiction. Think the killer machines in the Terminator movie, or the replicants from the world of Blade Runner. The prospect of so-called living robots and using technology to create living organisms understandably raises concerns for some, said Levin. Quote, that fear is not unreasonable, Levin said. When we start to mess around with complex systems that we don't understand, we're going to get unintended consequences. Nevertheless, building on some simple organic forms like the Xenobot could also lead to beneficial discoveries, he added. Quote, if humanity is going to survive into the future, we need to better understand how complex properties somehow emerge from simple rules, Levin said. The findings were published online January 13th in a journal proceeding of the National Academy of Sciences. Thank you all for watching. I have merch. Be sure to like the video. Thank you.